All right, example number 4. Write a and b in radical form. Write c and d in exponential form. Now, what we're going to keep in mind here is a to the power of m over n can be written as a, the nth root of a to the power of m. And alternatively, we can work our way backwards and say a to the power of m. Sorry, I messed that up. We can work backwards and simply say a to the power of m, the nth root. So the nth root of a to the power of n can be written as a to the power of n over n. Now keep in mind that this exponent here also can be written just above the a. It's the same thing. All right. 40 to the power of 2 over 3. Well, I would take my base 40 and I would apply the cube root first. Cube root of 40 squared. Or alternatively, you could write it as the cube root of 40 squared. Now, I wasn't asked to evaluate it, thankfully, because I don't think I can do that. Now, 26 to the power of 2 over 5. So I take a look at my denominator. I'm going to write 26 becomes my radicand. So it's really the fifth root of 26 squared. Or 26 squared fifth root. Pick your poison. Now, write c and d in exponential form. Now, I always find it helpful that if I'm missing my index, that I put my index, and that index is 2. So I got rid of something that I might have been actually helpful to see. There, that stuff. So right now we're going to use this scenario. It's given in radical form. We're going to put it in exponential form. So let us do that. We're going to focus in on here. So like I said, I'm just going to put my index for a square root. And I could write this as 3 to the power of 5 over 2. Now, my nth root is 4 to the power of 3. So I know my exponent is going to be 3 over 4. And my base is 19. Now, fair enough. And perhaps you're wondering, we've never seen this before, but really you have. Like, what is 2 squared? Everybody knows that 2 squared is 4. Now, I'm not trying to confuse you, but 2 to the power of 2 over 1 is also 4. So there has been a denominator there. We've just chosen not to write it all along. And our notation definitely works out well with us. All right. So now, when we are asked to solve or evaluate, we're going to put the expression in radical form. Okay, sure. Why radical? The radical form is going to be the best for us because that's the one we understand best. So we're going to evaluate the radical, and then we're going to complete the questions if any steps remain. So really what I'm going to be doing here is I'm going to evaluate 0.04 to the power of 3 over 2. I am going to move this as 4 over 100 to the power of 3 over 2. Now, the reason why I did that is because it makes it so much easier. In my mind, anyways, I can do it another way. So now I'm going to apply the radical. So it's really 4 to the power of 100, square rooted, all that to the power of 3. What is this square root of 4 over 100? Now, you can apply your square root independently to the numerator and the denominator. And really it's 2 over 10. So 2 over 10 to the power 3. And that is going to be 2 cubed to 100, or sorry, to 10 cubed. 2 cubed is 8. 10 cubed is 1,000. Now, if you want, I don't have to change it to a fraction. I could have left it as a decimal. Except for I better know my decimals really well. What two numbers multiply together to give you 0.04? That is 0.2. 0.2 cubed. Well, that is going to be yielding, so 8 and then 3 decimal places. Right? It's kind of a tough question. All right. So let us evaluate the radical first because it takes down that number very small. And let's raise it to the exponent. So for instance, negative 27 to the power of 4 over 3. First thing I do is I'm going to write it as the cube root of negative 27. And then I'm going to raise it to the power of 4. Now notice in brackets, negative 27 to the power of 3, this is going to be negative 3 to the power of 4. Negative 3 to the power of 4 is negative 3 times negative 3 times negative 3 times negative 3. Or it's really 9 times 9. So this answer is 81. Whew, this one looks nasty. Negative 32 to the power of 0.4. If you want, you can try this out on your own by pressing pause, or press pause and punch it into your calculator, see what you get. I'm going to start this right away. First things first is I take a look at that exponent, and I'm like, I don't know what Mr. Moran's talking about simply because it's a decimal. Well, what do you know? Well, we do know rational exponents when they're fractions. So I'm going to take 32 to the power of negative 32 to the power of 4 over 10. I can change that decimal into a fraction, and yeah, sure. And maybe I have a sneaky suspicion. Okay, can I ask you a question? Right, 10 is going to be the radical, the 10th root. Wow. What number multiplied to itself 10 times gives you negative 32? I have no idea. But if I take a look at this exponent, what do I notice about the exponent? Well, the exponent can be further simplified into 2 over 5. I actually think I'm in business now. I think I get this. I know where it's going. So what I'm going to do is I'm going to say negative 32, the 5th root of negative 32. And then I'm going to square that number. So what number multiplied to itself 5 times gives you negative 32? It's negative 2 squared. This answer is 4. Notice how I chose to evaluate the radical instead of the exponent. This is entirely right, but you'll notice you'll say give right away. All right, so I'll go negative 32 and to the power of 2 over 5. I'm going to choose to evaluate the exponent first. So I could write negative 32 squared, and then what I'm going to do is I'm going to do the 5th power of that. Now this seems very odd, doesn't it? So negative 32 times negative 32 is Yeah. Is 1,024. Now, what is the fifth root of 1,024? What number multiplied to itself 5 times gives you 1,024? Quick. That's right, it's 4. Not intuitive whatsoever. That's why it is better to work with the radical first and then raise to the exponent.